So we're taking a look back at 1.8 and 1.9 to help us prepare for 2.4. I hope that's okay with you. A little bit of a nice little refresher on what we've done so far with arithmetic and geometric sequences, seeing what the next few terms are in the table for a sequence. This is obviously adding 4 over and over. So 15 plus that 4, we get you 19. 19 plus that 4 gets you 23, then 27. 2 and 3 are awfully similar, nothing too crazy there. I'll leave those to you. However, we're dealing with arithmetic sequences here, or as we saw them in Unit 2, they were rewritten as being linear, which means they're in a straight line. There's a consistent rate of change. We've seen some problems like this. They weren't too bad, but we now, again, want to practice the method we've been using where, although this is one term and yeah, it looks easy, and I'm sure some of you could just guess it, that's kind of lazy to me. I want to really see that you understand what you're doing, not just guessing and getting lucky. So what are we going to do? We're going to take a look at how our first term is 5. And since this is arithmetic, we would just keep adding some x term over and over. And in this case, we add 2 of those x terms, which would eventually get us to this squared term here. Not square, but it's in a square shape of 11. So this is how you should be solving these arithmetic problems, thinking, what's your starting point? What's your stat? How many hops do you keep taking? In this case, we take 2, count them 1, 2, and then what's the final term that you are ending up with, which in this case is 11. If we solve this, we've talked SADMET before. We can deduct 5 to try and get a hold of our common difference, which is here. We're left with 2x. This equals 11 minus 5, which is 6. So x is 3. So this means that every time we move forward, we're adding 3. So 5 plus 3 gets you 8. 8 plus 3 gets you 11. This all makes sense. So we're good there. 2 and 3 are pretty much the same song and dance. 12 is a little tricky, but take your time. Count the hops. We have 1x, 2x, 3x, 4x, 5x, 6x. So starting at 12, we add 6 versions of our common difference, and it should get us to -6. Recall SADMEP, opposite of positive 12 is a -12, so we want to subtract 12 at first. We're left with 6x equals -18. 6 is multiplying with x, so we want to undo that with division. Divide by 6. X is now -3. So every time we move forward, we're deducting 3. Deduct 3, deduct 3. Keep this going. We'll hopefully get to -6. Let's try it. 12 minus 3 is 9. 9 minus 3 is 6. 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is -3. -3 minus 6 is -6. Lo and behold, everything checks out. Arithmetic's pretty simple. We'll see that it does heat up shortly, though. Real G's multiply their money. So starting at 3, we multiply with some x term. Multiply again with some x term. Just heads up, this is the 1.9 set, and we're working with geometric sequences. So recall, real G's multiply their money. In this type of sequence, we're multiplying every time we move forward. So we can still make an equation similar to arithmetic, but we have to be a little bit more strategic with how we do that. So still start at the same term of 3, but now we multiply by some unknown term once, twice. So that makes our exponent what? What do you think this exponent here is going to be? We know we're eventually going to get to 12, but we're multiplying by x twice. Okay. This should look like something we can solve kind of similar to SADMEP, but not quite. Here, let's take the ride. 3 is multiplying with x squared, so we want to divide by 3. X squared could be equal to 12 over 3, which is 4. Psych, this should be that. We can take square roots. Since it's an even exponent, we can have two answers here, so plus or minus. Square root of 4 is just 2, so this means that every time we move forward, we could be multiplying by 2. 3 times positive 2 gets you 6. Or we could be multiplying by -2, which would get us -6. Eventually, if we're consistent with either route that we take, we get to 12. Is the missing term that you identified the only answer? Why or why not? There are two answers for our missing term, and we just showed them. What do you think about 2? Pause the video, try it. Your equation should have been 7 times x cubed equals 875. Divide both sides by 7. X cubed is now equal to 125. If we take a cubic root, because it's being taken to the third power for our variable, so cubic root, we're thinking what term when multiplied by itself once, twice, 3 times gets you 125. The only number that works here is going to be +5. So how does this help us? We know that we have this common ratio, our CR, of 5. So let's hop back here and think out. If we keep moving forward, multiplying by 5, 7 times 5 gets you 35. 35 times 5 gets you 175. Boom. 175 times 8. 175 times 5 gets you 875. So in this case, are the missing terms that you identified the only answers? Yes. Why is that? Because we're taking a cubic root. So we're taking a cubic root of a positive number. If it was an even root, we could have two answers, but since this is cubic, it's an odd number, you know, like 3 or 5 or 7 or 9. And since it's a positive number that we're taking that root of, there's only one answer we can end up with. Let's take a look at problem 8 just for kicks. Starting with 2, I keep multiplying once, twice, 3 times. So 2 times some number 3 times, meaning it's being cubed because it's multiplying by itself 3 times, gets you 128. If I was going to go for x, x cubed equals 64, just like Nintendo. If I take this further and take our cubic root, what number, when multiplied by itself 3 times, just like this, gets you 64. Hopefully you're saying 4. So 2 times 4 gets you 8. 4 times 8 gets you 32. Let's check this. 4 times 32 gets you 128. So I think it's good. It matches. Our explicit equation, starting with 2, we multiply by 4. Since 2 is the first term, we have to give respect to that and be 1 away. So x minus 1 times. So that's one way we could write it if this was our term 1 version. We could also have started at term 2. So it's starting at 8. We multiply by 4, x minus 2 times. That could have worked. What's cool is that when you get into this habit of noticing what term you're talking about, you could keep going like this forever. 32 multiplying with 4, x minus 3 times, that could work. And just because I'm on a roll, what do you think term 4 would be? We know it's multiplying by 4. We know that our exponent has to show respect to being the 4th term. So x minus 4 is there. And we start with 128 because that's our 4th term. So lo and behold, you have 4 different ways you could have written the explicit equation. I hope that this video was helpful and you're prepared for 2-4. Thanks for watching.